A particle A having a charge of 5 times 10 power minus 7 coulomb is fixed in a vertical wall. A second particle B of mass 100 gram and having equal charge is suspended by a silk thread of length 30 centimeter from the wall. The point of suspension is 30 centimeter above the particle A. Find the angle of the thread and the vertical when it stays in equilibrium. So let us understand by drawing a figure. Let us consider it's a wall. So in this wall, a particle A is suspended. Let it have a charge plus Q. It is having 30 centimeter. And second particle B of mass 100 grams having equal charge is suspended by a silk thread of length 30 centimeter from the wall. So from this wall, another charge, same charge, also suspended, and this is also length of 30 centimeter, and it is having mass 100 gram. Since they both are positive charge, so there is a Coulomb force of repulsion which acts along in this direction. Not only that, since it's having weight, so gravity is also acts downward directions. So this is the mg and this is Coulomb force. Now if the particle stays equilibrium, we need to find what is the angle between the thread, suspension thread, with the vertical. So we need to figure it out. What is theta? Theta is equal to how much? So that is our task. So for that, so let me draw similar figure. Suppose a particle is suspended at here. So this is a particle of length 30 centimeter. That is the O is suspension point and A is the particle. So let it is having a positive charge. Another particle, suppose if I take another particle, so that is at there. Now this particle is also having same charge plus Q. So this is particle B. So I would like to show the Coulomb force. The Coulomb force will be acts along in this direction, Fe, and gravity also acts along downward direction. The mg will acts along downward direction. Now from the given figure, so since it's a thread, tension will be acts along in this direction, and this length of the thread is 30 centimeter. Suppose if I draw a line from A to B, so there's imaginary line in the direction of the Coulomb force. Now if I take this angle as a theta, now OAB looks like an isosceles triangle. OAB is an isosceles triangle. So if it's an isosceles triangle, So two sides and two angles are equal. Suppose if I take this is an angle and these two angles also gets equal. So before that, it's better to bring the Cartesian sign conventions. So suppose if you draw a Cartesian sign convention, a coordinate system at here. So I wish I carefully draw a coordinate system along in this direction. Along the downward direction, and x-axis is along in this direction. So this is, you can take positive x-axis and this you can take negative x-axis. And if you take the angles which they are measuring at here, so this angle I could take as alpha, and opposite angle to that, this I'll take as beta. If this is beta, since it's isosceles triangle, this is also will be beta. And the mg is making an angle with the y-axis is theta. Okay. Now the force Fe is resolved into two components. Along x-axis, this I can take as Fe cos alpha, and along in this axis it will becomes Fe sin alpha. Similarly, mg is also resolved into two components. Along in this axis it will becomes mg cos theta, and along in this axis it will becomes mg sin theta. Okay, since it is in equilibrium, some of the forces should be equal. It means upside forces should be equal to downside forces, and left side forces should be equal to right side forces. So here upside force goes to tension equal to Fe sin alpha plus mg cos theta. So these two forces are equal and opposite, so they cancels out each other. But to make opposite to the positive charge, since they both are the positive charges, we need to make it equal. Mg sin theta component which equal to Fe cos alpha component. So these two terms do not cancel out each other. So if these two forces are equal and opposite, so then only the two charges should be in equilibrium. So to calculate the angle set here, so from triangle OAB, I can take from triangle OAB is as isosceles triangle. So sum of the angles 2 beta plus theta equal to 180 degree. So from this you can get the beta value, beta equal to 90 degree minus theta by 2. So this is the angle you can get from the isosceles triangle. Similarly, the opposite angles alpha plus beta equal to 90 degree. So you can substitute the beta value at here to figure it out. Alpha plus 90 minus of theta by 2 equal to 90 degrees. So 90 degrees 90 degrees gets cancelled, and alpha equal to theta by 2. So I can substitute alpha at here in the later session. So for that, now I need to make it equal that two forces, that is mg sin theta and fe cos alpha. So we can make it equal that to mg sin theta and fe cos alpha. So let me take new blank page or fresh. So therefore mg sin theta equal to fe cos alpha. Now from the above expression, theta equal to, from it here, theta equal to 2 times alpha. Therefore mg of sine 2 alpha equal to fe cos alpha. Fe stands for electric force. Mg, so sine 2 alpha you can expand 2 sine alpha cos alpha, that is a trigonometric identity which gives fe cos alpha. So there we use a formula sine 2 theta equal to 2 sine theta cos theta. Now cos alpha gets cancelled, so the remaining terms 2 mg sin alpha equal to fe. From that you can write 2 mg sin alpha equal to fe Coulomb force k times q square by r square. So there r square is the distance from between the two charges. So distance between the two charges, here this we can take as r. So let it equation 2. So now this you can take as 1 and this you can take as 2. Now to go further, so I would like to use one of the trigonometric identity from triangle OBC, from triangle OAB isosceles triangle. We can use one of the trigonometric identity, that is the identity stands c square equal to a square plus b square minus 2ab cos theta. Here a, b, c are the isosceles triangle sides length. Okay, so this identity I am using directly. So from this I can write as cos theta equal to a square plus b square minus c square by 2ab. So this is the identity I am using to solve further. So from the identity from triangle ABC, OAB by trig identity, that is c square equal to a square plus b square minus 2ab cos theta. So therefore cos theta equal to a square plus b square minus c square upon 2ab. Now if you convert that ABC in terms of the given length, here a equal to, I can take as L, B is also L, so in terms of 30 centimeters they both are equal, and C equal to R. So I can substitute that cos theta equal to L square plus L square minus R square upon 2L square. So if you can simplify that, cos theta equal to 2L square minus R square, it's a 2L square minus R square upon 2L square, which is also equal to 1 minus R square upon 2L square. Now we can do further simplification. Cos theta equal to 1 minus r square upon 2l square. So I like to write what is the r square term from there. So you can do the cross multiplication and simplify that. R square equal to 2l square of 1 minus cos theta. Okay, since theta equal to 2 times alpha, so r square equal to 2l square of 1 minus cos 2 alpha. So let it equation 3. Now you can substitute r square value in the equation 2, since at here we need to find out what is the r square. So therefore you can put it 3 into therefore I can get 2 mg sin alpha equal to constant, Coulomb constant, ke q square upon r square value I got there 2l square of 1 minus cos 2 alpha. Now we can do further simplification. So 2 mg sin alpha equal to Coulomb constant ke times q square upon 2l square of 1 minus cos 2 alpha. Cos 2 alpha you can write 2 cos square alpha minus 1. 2 cos square alpha minus 1. So this is also one of the trig identity, since you can write there cos 2 alpha. I can mention, since cos 2 alpha equal to 2 cos square alpha minus 1. Now simplify the above expression. 2 mg sin alpha equal to ke times q square upon 2l square of 2 minus 2 cos square alpha. Now almost getting equal, we can take out the 2 common. 2 mg sin alpha equal to ke times q square upon, if you can pull 2 outside, it will becomes 4l square times 1 minus cos square alpha. So 2 mg sin alpha equal to ke times q square by 4l square. 1 minus cos square alpha you can write as sin square alpha, since 1 minus cos square theta equal to sin square theta. Now rearrange the terms. If you can rearrange the terms, you can write sin cube alpha equal to ke q square upon 8l square mg. So sin alpha equal to cube root of ke q square upon 8l square mg. Since alpha equal to theta by 2, therefore sin theta by 2 equal to cube root of ke times q square upon 8l square mg. So theta by 2 equal to sin inverse of cube root of ke times q square upon 8l square mg. So theta by 2 equal to sine inverse of cube root. You can substitute the values ke, Coulomb's constant. So that I can take as 9 times 10 power 9 times charge. It is a 5 times 10 power minus 7 whole square upon 8. Length is given 30 centimeter. So L square, if you can convert that in terms of the meter, 0.3 square meters. 0.3 square meter, and the mass is given in terms of 100 grams, that will becomes 0.1 kg, and gravity 9.8 meter per second square. If you do do the simplification, you can get the value of theta. So therefore theta equal to 2 times of sine inverse of cube root of, so 9 times 10 power 9 of 5 times 10 power minus 7 whole square upon 8 times 0.3 square times 0.1 times 9.8. If you can do by using calculator, so the theta value will get 16.916 degree. So this is the angle theta. We need to find what is the suspension angle. So it's too lengthy problem and too mathematically tough problem. So the angle theta equal to, I can mention that 16.916 degrees equal to theta.